A warm welcome to our session, Why Aren't My Tests Stable? Before handing over to my colleague Michael Sauter, I would like to inform you that we have roughly 15 minutes for Q&A. So I would like to invite you to post your questions in the chat, and we will have time in between and after the presentation. And with this, I would already like to hand over to my colleague. Michael, over to you.
Thank you, Tanya. So also a warm welcome from my side. And I guess most of you are here already ask themselves the questions of why aren't my tests stable? And quite often the answer is missing test isolation. So that's why we're going to talk about this now. First, a quick introduction of myself. I'm Michael. I've been with SAP for over 10 years now. I'm working as a software developer in the ABAP platform department. I'm also working as Scrum Master. I'm a trainer for agile software engineering. I'm active in the Clean ABAP guide, which some of you might know. So yeah, everything ABAP and software engineering related. And with that, let's go straight to the topic with some motivation. So first step, why do we even want to automate testing? Well, it's simple. Manual tests need time and therefore cost money. We want to avoid that. Additionally, manual tests have gaps because some cases are pretty hard to test manually, like system configuration, customizing, error cases like network outages. That's hard to test manually, but with automated tests, we can simulate that and make sure our application works accordingly. Additionally, we gain good protection again from regressions. So we avoid repetitive manual tests after changes and can still be sure that the existing old features still work, which also leads to one of the, from my point of view, most important parts, more fun in development. Because if I don't have to worry about whether I might break a feature with my refactoring, with my improvements of code quality, I can just adapt stuff without having to worry and therefore have more fun with better code. Then why test isolation? Well, first of all, I already mentioned simulation. We want to simulate error cases. We want to simulate user input. We want to simulate system configurations. But apart from this simulation stuff, we also have the topic of easier error analysis. Because if I really only have the test check one single method and the test fails, well, I'm sure the issue is in this method and not somewhere else in the system. This testing of just single units also leads to shorter runtime, and we can avoid unwanted output of other components we might use. The typical example for this is if you have a printer service attached to your application, well, you don't want to really print stuff when running your tests. So test isolation also helps there. That's just a few points. There's a lot more, but that should give you an idea. Now, just to be sure we're all talking about the same stuff and have the same understanding of the same terms. I already used some of those terms, but I'll go through them, yeah, just to be on the same page here. So first of all, we have the concept of code under test or CUT. So we have tests, and these tests make sure the code under test works as intended. But in reality, code under test isn't one thing that's just there on its own. Usually code under test has other components that are used by the code under test. These components that are used by the code under test are so-called dependent on components or docs. So when I talk about docs in the rest of the presentation, I mean components that are being used by the code under test. Unit tests aim to break exactly this dependency. So we want to make sure that only our code under test is checked and not the functionality of dependent on components. And we achieve that through something called a test double. So something that replaces the dependent on component during the test, simulating a certain behavior of this dependent on components, be it expected output, exceptions, whatever. Then we have a mechanism that's called injection. Injection is the act of replacing the dependent on component with a test double. Simple as it is. Then something, I included it, but probably most of you know that because, I mean, it's already in the title of the presentation. ABAP Unit. ABAP Unit is a framework that's integrated in the ABAP language itself with specific keywords like for testing, risk levels, durations. And it is intended to be used for unit tests, as the name implies. But it's not necessarily only used for unit tests, because as we just heard, unit tests are not defined by the tool that's used to implement them. They're defined by not accessing dependent on components and rather have them replaced with test doubles. So with the terminology here, we have to be pretty careful when talking about tests. So tests with ABAP Unit don't necessarily have to be unit tests. Then ABAP Unit isn't just one of a unicorn. It's part of the X Unit family. The X Unit family was introduced by Gerard Messaros in the book X Unit Test Patterns. And basically, he laid the foundation for ABAP Unit, JUnit, QUnit, several other testing frameworks, which are intended for unit tests in different languages, different technology stacks, and they all behave the same way. They all have the same ideas underneath it, namely the X-Unit idea. And with that, with these terminologies clarified, we can take a look at isolation techniques, especially one that's basically the default when you work with object-oriented ABAP programming. It's a way to make sure you can replace your docs in your tests rather easily and in any test case. And the setup we have here is you have an interface for your code under test. You have a class implementing that interface. You have an interface for your dependent on component, and you have a class for your dependent on component. Now, in the usual way of the application, when the application runs, somebody accesses the interface of the code under test. The code in the class gets executed, and that class then asks the factory for an implementation of the interface of the dependent on component. So this class, the code under test, only uses the interface defined for the doc. The factory then instantiates an object of the class of the dependent on component and returns that, and everything runs as expected. Now, in the test case, we want to inject a test double, and we can do that with an injector. So the things that just joined in that picture are the test double, and the injector. And how these things play together is as follows. We have the test that creates an instance of the test double of the dependent on component. And this test double is a class that implements the same interface as the dependent on component. Then the test uses an injector to put that double into the factory. And when the test now accesses code under test, and the code under test asks the factory for the dependent on component, the factory simply returns the double. That's a pattern that can be used with any kind of object-oriented ABAP dependencies. As long as you have classes and interfaces, that's the way to go, basically. There are other ways. That's one you can basically apply to anything. And that was the first part of the slides of just getting the pattern, getting the terms, getting the motivation done. Now, I would like to ask Tanya, are there any questions so far?
Here we go. No, currently we don't have any questions.
Okay. Then I'll just jump right into the code. I hope you all can see it. And right, so
It is visible, yes.
Perfect. Thank you. So I set up a small example here. So basically we have our code under test. We have a dependent on component. We have factory. We have an injector. We have interface for the code under test and the dependent on component, and some other stuff we're going to take a look at later. And the way this example is set up is this code under test has different interface methods with different kinds of dependencies you want to isolate yourself from. One is the just mentioned objects with methods, and you want to insert double for that object. Others are probably not as straightforward to get the double in there, like function modules, database tables, CDS, so core data services entities, authority checks, and also RAP, so RESTful ABAP programming entities. But for all of these, there are ways to isolate from what these docs are doing. And now I'll go through each of those and show you how you can isolate from that. The first thing is what we've just seen in the slides. So we have our code under test. It has a method called call other object. And in that method, it asks the factory for an implementation of that dependent on component, and then calls a method at that and just returns whatever the dependent on component returns. In our test, we now go ahead and in the setup of that test class, instantiate our code under test. And in the test itself, we instantiate our double. Make sure it returns the value 2 in this case, in this specific test case. Then we use the injector to inject that double into the factory, call our code under test, and check that the value we defined before, the 2, is also returned now. So first thing, we have a test double here. That class name starts with LTD. LTD is short for local test double. So basically I defined a class here, and it implements the same interface as dependent on component and has an attribute for the result it should return. And then in the part of injecting this double, you can take a look at the injector. And what this does, it accesses a static attribute of this factory and just puts the double there. And what the factory then does, if we look at the productive method of that factory is it checks if that dependent on component is bound or not. It's only bound if an injector puts something there. So only in test cases it is bound. And when it's not bound, we instantiate the productive dependent on component. When it is bound, we return the double. Pretty rather straightforward. Now, a lot of people argue that implementing own local classes for test doubles is kind of cumbersome. And mostly you want to do stuff like, hey, return the following number anyway. So there is a framework to help with that. And that's the ABAP Object-Oriented Test Double Framework. That's a framework that helps you with instantiating a test double, which implements a certain interface. And you can call that using CL ABAP test double. And you basically tell that class, hey, I want an instance of a test double which implements that interface. And you get that. Afterwards, you still have to make sure that it follows the expected behavior. So in this case here, we say, dear test double framework, please make sure this test double returns a 1 if the test double is called, if the method add of the test double is called with these parameters. And then we have the same, basically a test double that does the same thing as in the other class, as our locally implemented test class. And from this point, we can use the same injector, do the same calling our code under test, and the same of asserting the result. So these are two ways how you can get test doubles for ABAP classes into your factory or inject them, use them in your tests. They both work. From my personal experience, the important thing is that your team, your development organization agrees on how you want to do it. So there is one consistent way of how tests are implemented. Otherwise, there's a tendency of things getting messy and inconsistent. The next thing is calling a function module. So we have a public method called call function module, and what this method does is it calls a rather well-known function module, pop-up to confirm, that when called in a SAP GUI application, just gives the user a pop-up with a yes, no, cancel option. And in our tests, we obviously don't want that. First of all, because they're automated tests, no one should be sitting there and responding to pop-ups. Second of all, automated tests might run in the background, run in ABAP development tools, run in different settings than an SAP GUI transaction. And that's why you want to isolate from that. And that can be done with a framework called the function module test double framework, or function test environment if you follow the class name. So this test class is a bit bigger. It not only has a setup and one test method, it also has a class setup. So a method that's called before the very first setup is called. And so before anything else happens with this test class, we set up an environment and give that environment a list of function modules we want to isolate ourselves from, where we want doubles injected. In this case, it's just that this one function module. In our test, we then go ahead and say, okay, dear test environment, I want a double for this function module, and I want to create an output configuration. An output configuration is basically a set of parameters that should be returned with a certain value after the function module is called. And then we go ahead and configure that test double similar to the object-oriented test double framework. We take our test double and tell it, hey, if you're called, in this case, ignore the input parameters and return this configuration I just created, which in this test case returns a 1 for the exporting parameter answer. And if we now go ahead and call our code under test, we don't really open a pop-up, but that function module just returns a 1. And we also get that here. Then we do the same for the other values that might be returned by the function module, which are 2 for no and A for cancel. Not the nicest interface, but well. So that's it with function modules. The next thing would be database tables. In this case, we have an ABAP SQL statement with some aggregation logic. So we want to make sure that aggregation logic works as expected. And we want to make sure it works as expected based on some predefined data we have, not the data that's currently there in the system. And to do that, we can use the ABAP SQL testable framework. You might notice a pattern here. Here also we have a class setup, set up an environment, tell the environment what we want to isolate from. And in this case, it's the database table. And in our test, we then prepare. In this test, we want to make sure the aggregation works as expected. So we fill some data into our database table using this environment. And when our code under test is then called, the select statement doesn't go to the real productive database table in the system, but it uses the double created by this SQL environment. And afterwards, we can do our asserts, make sure the results are as expected. Now to a pretty similar thing. You see in the SQL statement before, we renamed parent key to sales order, and we counted SO item key as item count and grouped by parent key. Now, something like that, if it's needed in multiple places, can be done in a core data services entity. And in this case, that's exactly what I did. So here's a CDS entity doing exactly the same thing as a select before. So I want to test it the same way. I want to make sure this aggregation logic in this view works as I expected. And for that, I can use something that's called the ABAP CDS testable framework. Again, the same pattern, but here there's a slight difference. In here, we tell the environment, hey, I want to create a double for the following entity. So I'm not saying I want to isolate myself from the following database table, but I just tell the framework, hey, that's the entity I want to check. And what this framework then does is when this entity is used in a select statement, the underlying base tables are replaced with doubles, and data is taken from these doubles. So in here, in our test, we then go ahead and insert the same data into the same database table and expect the same results because the view and the select we had before do basically the same thing. Then something that was introduced rather recently is something to make sure authority checks work properly. At least when I started as a developer, that was a nightmare to try to make automated tests for it. And for a lot of people, it still is. But thankfully, there is a tool now to help with that. And that's the classic ABAP Authority Check Test Helper API. Long name, but helpful tool. So back to the productive code. What this statement does is it checks if my user who executes a test has display authority for the object as developed. Edit authority for the object as developed, which of course I do. I'm a developer on a development system. But now I want to make sure that this authorization check fails for people who only have display authorization. And I can do that with CLA unit authority check, where I first define a set of authorizations. So here I say, for the object as developed, I want only display authorization. Authority is the code for display authorization. And then I use this authority check to get a controller and restrict the authorizations to exactly that set. In that case, the set is one authorization on one object. And what I expect now is I expect the return code to be 4, because the return code 4 for authority check statements means not authorized. And that's exactly what happens here. So I just realized I didn't run the tests before. But all these tests in here are green. So we can see here also this test here, even though I'm a developer who clearly has development authorization on the system, gets the 4, so not allowed to edit, because I restricted the authorization for this specific test case. If I now want to check it the other way around, make sure it was not a fluke, I can now set the authorization to, for the same object, yes, I want edit authorizations. Then I can restrict my authorizations to that, call the authority check, and now I get a result of 0, which means I'm authorized. So that's pretty handy. And without that framework, there were workarounds, but no really clean solution, at least none that I knew of, to be honest. And the last thing you might want to isolate yourself from are RAP business objects. But for that, I'm gonna jump back into the presentation for 2 slides, because probably not a lot of you have worked with RAP a lot. So I want to give a really short introduction. So RAP is the RESTful ABAP programming model. And it is basically a way to describe business objects and work with these business objects, work with the data in there, with methods that are with language elements, which are part of the ABAP language. In the past, we also had stuff to work with business objects like BOPF, for those of you who know that. But RAP now is really integrated into the ABAP language with specific language keywords. And most of those are the EML, the entity manipulation language, which can be used to get data, create data, change data, delete data. And because these are specific language elements, it's pretty hard to isolate from that without tool support. And that's why there are 2 ways to isolate from that. One is the transactional buffer double, which is basically, yeah, exactly what the name says. So when the EML statement is executed, it calls the RAP framework. and that accesses a transactional buffer to get data, change data, and the transactional buffer double. Well, it replaces the transactional buffer. That's kind of obvious. The other option you have is the mock EML API, which takes a shortcut, and you basically just define what your EML statement should return. And I'm also going to show you that in the code now. So the EML statement we have here works with a demo entity for travels. And this statement here is supposed to create an entry in this travel entity with a certain agency ID, a customer ID, some description text, some behavior control, whatever. And it returns 3 values: reported, failed, mapped. I'm not going to go into the details of what those are. That's for a different RUP specific session. But we want to isolate from that because this thing changes stuff in the database. We don't want that in our test. So the transactional buffer double also follows a similar pattern as most of the other frameworks. So we get a configuration for our environment with a certain entity, that the one we're using, and then create an environment for that. But then there's something different. In the setup, we go ahead, get a test double for the specific entity, and set a fields handler. This fields handler is basically the thing replacing the transactional buffer. That's the thing that happens, that's called when your EML statement is executed. So in our case, that's again implemented in a small local class. It just sets an ID to a certain numeric value. Nothing spectacular, but just to have some logic there to make sure the call goes all the way through. And with this configuration of the double, with this field handler, we can now call our business object and then assert that stuff happened. In this case, we want an entry in the travels with, we want one entry in the travels. The alternative to isolate from RUP business objects, the mock EML API, is even closer to the other frameworks in the sense that you again create your environment and then you go ahead and just define your value, create a double, create a defined output, and then tell the double, hey, if you called for modification, ignore your input and return this given output. And when we then call our code under test, it returns certain values, and we again expect one travel entry. Pretty easy. So that's the code. I don't know if that question already came up in the chat, but you can find the code via my GitHub. I'll have that link somewhere later. Yeah, so don't worry, you can find the code if you want. But first, a quick summary. I personally made that table because I was confused quite a lot of times when wanting to isolate my code under test. And yeah, for me, it came in handy quite a few times, so I wanted to share it. So with the question, how can I isolate my code under test from the dependent on components? It's always the question of what's your dependent on component? And if it's a class, you can go ahead, implement your own test doubles or use the object-oriented double framework. If you want to isolate from database table or CDS entities, use the SQL test double framework. If you want to isolate from function modules, use that test level framework, and so on. That's probably the shortest summary you can find of how you can isolate your tests. And with that, yeah, here's the link to my GitHub, github.com/sauterme0. And yeah, the only thing I can say is thank you. And I'm handing back to Tanya for Q&A, if there are questions.
I'm just trying to get my video running. Okay, someone got frozen. Here we are. We have one question. That is, it would be very helpful if you could cover how to handle messages, as this will surely make the testing failed if not handled well, pertaining to TDD approach.
So I assume you mean the message statement. So that depends on how you want to use that, where you want to use that. Usually, a message statement shouldn't make a test fail. I mean, in the end, it's just taking a translatable text and adding some parameters in there. From that point of view, that shouldn't make a test fail. If you don't see any other option, there's always the way to encapsulate your thing you want to isolate yourself from, let's say a message statement, put that in a separate class, put that in behind a separate interface, and then go the way of how you can isolate from objects, from other objects. That would be the generic approach, just grab the thing you want to isolate from in an object. But if you have more concerns on message statements messing up your tests, please, I don't know if I can see the videos under the comments under the video afterwards, but please explain how that's an issue, and I'll do my best to provide updates on that.
Thank you very much. So we still have time. If you have any follow-up question, feel free to post it in the chat. And in addition, I will now, actually, I already posted the code samples and where attendees can find the release information. I posted in the chat, but I will also post the link where your presentation can be found. And that's also where our attendees can find your contact information.
Yeah.
So in case any follow-up questions arise, which often happens, I think you'd be happy to answer them, correct?
Of course, yeah, sure.
So this is the link, presentation. Here we go. So give it ideally until Monday, because actually my colleague is on holiday. But he will upload Michael's presentation there. And of course, feel free to add any questions, comments in the comments area, contact Michael, contact me. Happy to provide any questions that you might have. And so if no further questions are asked, Michael, a heartfelt thank you for your excellent presentation.
More than welcome.
And a big thanks to our attendees for joining. I hope the session was valuable for you. And I hope we will see you again in one of our next presentations. The link I just shared, you can find further knowledge transfer sessions that we offer in particular for the user groups. There is a question. Do you have any examples on how to test a function module itself?
I don't have an example right now, but it's basically, well, that doesn't sound like a smart answer, but it's basically the same. So let's just jump to a random test class here. Basically, the only thing you do differently between testing a method and testing a function module is right here. You call your function module instead of the method you want to test. That's basically the same thing. You call it with some parameters and you assert that the right stuff comes back as an exporting parameter. So you can just do that the exact same way. Hope that answers the question.
Okay, any other questions? Does it include Z99 or how?
Sorry, I didn't get the question.
It says in the include Z asterisk 99 or how?
Okay, I think I don't get
Of the function group.
I need to.
Perhaps how about
the function? Now I have an idea where that question is going. If you want to test stuff that's in a specific function, in a specific include of a function group, it's probably my personal recommendation would be to add one include in the end of your function group with the test classes, because that include then has access to everything in the include before. And there you can implement test classes just like this one, but then calling your function module instead of this method. Otherwise, if you want to test your function modules, you could also go the way of creating global test classes, like one global test class for one function module, for example, and do your tests there. Then it's separate. You're sure you only check stuff that's available through the real interface of that function module through the signature, and you don't rely on some implementation internals. Yeah, so either an additional include or a completely separate global test class would be my recommendation.
I think this answers his question
Okay.
because it's, he mentioned, okay, thanks.
Okay, good. You're welcome.
And then I have a not totally connected to your presentation, Michael, but there is an attendee new to SAP ABAP, and maybe you have any suggestion to your good YouTube channel or any other learning on ABAP. The person wants to learn new things in programming.
So what I found most helpful is reading old code and troubleshooting. So I did quite a bit of what we call hotline duty. So support for people who have issues with some applications, because there you crawl through all the code people have built through the years, different people from different departments with different backgrounds, and you see so much different ways of building software. For me personally, that was really helpful. Seeing how different people have built software and still build software, and try to, see a lot and then form your own perspective and ideas based on that. Apart from that, reading material-wise, clean code is the basic thing. If you have a lot to do with older code, there's a book called Working Effectively with Legacy Code, which is definitely a recommendation from me, because it helps with, you have old code and want to build new stuff, enhance it, adapt it. It helps with methods on how to do that. So these would be two ideas on what you could read. And apart from that, build stuff and get yourself someone who's experienced to review your code and get your hands dirty.
And what about the OpenSAP?
Well,
do you think
of
they
course.
might have also courses?
Right. I'm so sorry. Yes. Yes. There's a course on OpenSAP called Writing Testable Code. That's the recommendation, more than 100% recommendation. That it doesn't contain all the latest stuff, but it's a great collection of starting with what I did in 2 slides with a why even testing, why test isolation. It gives a lot more background on that. And it also has pretty well thought through exercises you can do to try different approaches to test isolation. I mean, I showed the factory and injector approach, but there are different ones. And this Writing Testable Code OpenSAP course goes into much more detail on that. So that's definitely worth a shot.
And I'm sure OpenSAP, I mean, they have, I don't know how many courses they offer. So whatever you are interested in, I'm sure they'll be able to, provide some insights.
Yeah.
And the other is the SAP community. Just have a look at all the blogs posted there. That's also a recommendation if you're totally new. So I guess those two should be good.
Yeah.
To start.
Yeah.
Any other questions? So, and anyway, I posted the, if any questions come up, sometimes that happens, when you think about things and then afterwards, suddenly you have the question you would like to have asked. You can find Michael's email, contact details in his presentation, which will be uploaded. Please give it a couple of days, working days, to have everything uploaded. Yeah. So.
Or if you want to take the, sorry to interrupt, if you want to take the shortcut, you got the link with the code samples. If you have questions on the code or ideas, you can open an issue in that GitHub repository. That's basically the direct way to reach me on that topic.
Perfect. Thank you so much for the offer. Okay, then I would say if we don't have any further questions, once again, Michael, big thanks for answering all the questions as well. Big thanks for attendees for joining and for staying on. And with this, I wish everyone a great day, great evening, depending on where you are. And I hope to see you soon again.
Thank you.
Goodbye, everyone.